All right, ladies and gentlemen, welcome to the Build a Baby Lab. This was originally intended to be done in class with a partner. I've made some adaptations to this. Hopefully, this will work on your own at home. Uh, so, the purpose of this is to demonstrate the principles of Mendelian genetics and sex determination, including the concept of allele, phenotype, genotype, dominant, recessive, codominant, homozygous and heterozygous by creating a simulated baby. No, you are not actually going to make a real baby. Right? You are going to mix the genetics by random because that's how it actually happens in your body. And you are going to draw a baby. Let's see. Materials you're going to need. It says 2 pennies. That's because originally you're supposed to have 2 partners. You're only going to need 1 penny. It can be literally any coin. I don't care which. Uh, art supplies and paper so you can draw the baby. Procedure. Working with a partner, which you don't have, I have provided a partner for you. I'll show you what I mean by that in a little bit. Determine the genotype of the baby by flipping pennies, or nickels or dimes or quarters or whatever. Mom flips 1 penny to choose the allele for her egg, because remember, mom has 2 alleles. Head shall pass on one, tail shall pass on the other. Right? It is that random. And dad flips the other coin, to choose an allele for his sperm. Note that the sex of the baby is determined by the dad alone. Right, I'm gonna scroll down to your list over here. This is your second page, your third page. On the second page, sex is determined. Did I have it over here? I do not, and that's fine. Face shape. Okay, so sex is determined by the male because mom has 2X chromosomes. So this paper automatically came with an X because no matter what, mom is giving an X. Dad, male's in the room, assuming that you're going to be playing the role of dad, but to each their own. You're going to flip a coin, and heads, you pass on an X, tails, you pass on a Y. All right, so that's what you would put here. And then genotype, you would combine them. Mom's X and dad's whatever are written here. And then for phenotype, you tell me what the baby's going to be. All right, so if you got XX, baby's going to be female. If you get XY, baby's going to be male. Right? For all of the other traits, this next list here and the following page tell you what the letters mean. These are the phenotypes based on these genotypes. Right, so you are going to record the alleles which result from the coin flips and put sperm and egg together. That's the genotype. Write down the baby's genotype for each trait in table 1. That's what we just looked at. Heads represents allele 1, tails represents allele 2. So in most cases, heads will be dominant, tails will be recessive. Sometimes that won't be the case. Going down here, you'll notice that they're both capital. Up here, you have capital options, you have lowercase options. That's dominant and that's recessive. But here, we got 2 capitals. C1 and C2, they're both dominant. So in that case, if mom gives the curly hair, which is dominant, and dad gives a dominant straight hair, the baby will have 2 dominants, which means they both show up and they're going to blend together. And curly and wavy together, curly and straight together makes wavy. Your directions call that codominant, by the way. I noticed that when reading it to you. That is incorrect. This is a blend, which makes this incomplete dominance. Go back and check those old notes. All right. Record the resulting phenotype in table 1. Note dominant alleles are written with the uppercase letter and recessive alleles are written with the lowercase letter. Dominant alleles mask the expression of recessive ones. Codominant alleles are written as uppercase letters with a subscript, meaning is it incomplete dominant, not codominant, but I didn't make these directions. Are written with a subscript. That's the C1, C2 we just looked at. They're going to result in a blended phenotype. We're going to repeat steps 1, 2, and 3 for all the traits And when you are done, you're going to draw and color your baby based on what these say. And for concluding questions, meaning you actually do these afterwards, but feel free to do them first. I actually don't care which. I'm going to make some kind of Google sheet for this, maybe a Google form. I haven't decided yet, but it will be on Google Classroom for you to find. So why is the coin flip used to represent the selection of alleles? Why are we using a coin to decide? And then defining these words, uh, you should already know all of these words except for locus, which if this will let me write, no, it looks like this time it doesn't want me to write. Second, do it this way. This is the location of the allele or gene on the chromosome. All right, so if you're looking at the chromosome, this is where you are going to find the gene. Every gene has its own locus, and it sounds like location because that's what it means. All right, so how are you actually going to pull this off via the internet? All right, you have some choices here. You can print this page out. Like I said, you can answer these on a Google Sheet or Google form that I'm going to make, so don't worry about this page. And these, you can just look at your screen for these. So all you're going to need to print out is this page. If you don't have the ability to print anything out, that's fine. You can just write it down. Maybe I'll try to make a Google Sheet for this. I don't know how well that's going to work, but I can try something. Otherwise, you can just write it down on loose leaf. I'll be happy if you just take a screenshot of that and send it to me. Same thing with the baby at the end. Once you put all these genotypes together and you get all these phenotypes, you can use these shapes that are given to you to try to draw your baby. Now, I'm not grading you on being a great artist, and whoever made this paper also wasn't a great artist. Just do your best. When you draw your baby, again, take a picture of it, take a screenshot, send it to me via Google Classroom. So that's what I'm looking for. I am looking for these things answered. I'm looking for this filled in, and I'm looking for a drawing of a baby. How to put this together? First off, you can't be in partners, but every baby needs, partners, mom and dad. I took the liberty of filling in one of the parents. You will see two files on Google Classroom, one that says with mom and one that says with dad. I chose to use the one with mom as an example. I have filled mom's genes in for you. I flipped the coin myself. So you see here, mom, for face shape, has a capital R. So capital R would be dominant. So for a round face, lowercase r would be more of a square-ish shape. So dad, in this case, flips a coin. Heads, he would get a capital R. Tails, a lowercase r. Whatever that is, you put them together. Mom's big R with dad's whatever, and there's the genotype, and you find out what that means here. And that's going to be the shape you use for the baby. And you continue all the way down. If you prefer to be the mom, I already have one with dad filled out as well. Right, so you pick and choose. I already went over the, oops, I think not behaving now. There it is. The incomplete dominance ones, where they're both capital but same idea, except if you get a heterozygous, instead of dominant winning, they're both dominant, so they're going to blend. So you would get whatever this says to do. Down here, though, this is, whoops, let me do that. This is where people get confused often. Hair color and eye color are what we call polygenic traits. Polygenic means it's going to exist on multiple locations on the chromosome, right? Not just the one pair. You're going to have multiple pairs. In fact, hair color and eye color is actually 3 pairs, I believe. No, I'm wrong. They're 2 pairs. So 2 pairs, and you're going to have to flip a coin twice. One's for A, one's for B. So taking a look at mom here, mom flipped a coin, and she got tails for lowercase a. And then she flipped a coin again for a different location on the chromosome, and this time she heads and got a dominant B. Right? A is the first one, B is the second one. And then hide eye color, that's confusing there. Right? So just for hair color, she flipped the coin once and got her letter. She flipped the coin again and got a different letter. And then dad will do that for A and B. And then we're going to put them together for the genotype. The firsts, so mom's number 1 and dad's number 1, are going to end up together here. And then mom's number 2, dad's number 2 ends up here. And that's your genotype. And then you're going to use that to find out what the hair color is going to be down here. So mom had a lowercase a and a capital B. So lowercase a and a capital B here, lowercase a and capital B, lowercase a and capital B. So it could be any of those 3, but we don't know until the other parent puts it in. And then we'll find out what the hair color is. So yes, you are, when you draw your baby, you're going to have to color it in as well. Eye color, hair color, skin tone, I just said hair color, all the eyebrow color, all going to matter. All right. So if there are any questions, please feel free to email me or leave a message on Google Classroom, or come visit me during my office hours, which will be posted on Google Classroom. It will be available to Zoom. So I can actually put this back up on the screen, move my mouse around. You can ask me questions, and I'll show you right then and there what we're talking about. All right. You guys would have 2 days to work on this. I have this currently scheduled as a Wednesday project, so that's Wednesday and Thursday to work on it. I'm making it due Friday, but I will have my office hours for Wednesday and Thursday, either time if you want to talk about it. All right, good luck.